Good afternoon, everybody. Welcome to Tibbetts Physics Regents Review. What is crapping? Today, we're going to look at the force of friction. And we've got to deal with a couple of things with this. The first one is the formula. The force of friction, Ff, is equal to mu Fn. Mu is the coefficient of friction, and that's on your reference table. And it is unitless. Fn is the normal force. Now the key word for the normal force is that it's equal to the force of gravity on a horizontal surface. So Fg on horizontal surface. Now we could derive that by looking at A equals F net over m. Look at 2 videos ago on Newton's second law. When an object is sitting on a flat surface, the normal force is equal to the force due to gravity. Now, when we look at mu, we've got static and kinetic. Kinetic is the coefficient of friction while the object is moving. Static is the coefficient of friction to get the object moving. Most often, we look at the kinetic coefficient of friction. Now, one common scenario is when you're pulling something at an angle. So let's say we're pulling an object with a force of 50 newtons at an angle of 60 degrees. And we want to find the force of friction. So Ff equals question mark. So the first thing we know is that when you're pulling something on a flat surface, you're pulling it in the x direction. You're also pulling up in the y direction, but there's no vertical friction, so we only need to find Fx. So we look at our reference table. Fx is F cosine theta. Plug in chug, 50 newtons, cosine 60 degrees, and that gives us 25 newtons. So we have a net, or a force in the x direction of 25 newtons. Now, the other key word that I forgot earlier is that you're pulling this with a force of 50 newtons at a constant velocity. So let's add that there. Key word, constant velocity. Now, a constant velocity means it's not accelerating. Not accelerating means that the net force is equal to 0. So if we look at the net force in the x direction, A equals F net over m. In the x direction, we have the force in the x direction minus the opposing force, force of friction, over m. But the object's not accelerating, so we could get rid of A. If we multiply m over, we're left with 0 equals Fx minus Ff. And then we add Ff over. So we get Fx is equal to the force of friction. In this case, it's 25 newtons. So when you're pulling something at an angle at a constant velocity, the force of friction is equal to the force in the x direction. Let's look at an example where we have to utilize the coefficient of friction. So you're pulling a 10 kilogram wooden object on a flat wooden table at a constant velocity. We want to find the force of friction. So let's start with the formula. Actually, let's label everything. Mass, 10 kilograms. Wood on wood. So the coefficient of friction, and it's moving, we look in our reference table, is 0.30. And you want to find the force of friction. So we look at our force of friction formula. Ff equals mu Fn. Fn is the normal force. It's not the mass. In this case, it's on a flat table, so the normal force is equal to the force of gravity. So Ff equals mu Fg. But again, Fg is the weight, so we have to use a formula to calculate the weight, which is mg. Now Ff is mu mg. So now we can plug in our values. FF equals 0.30 times 10 kilograms times, we'll round it up again to 10 meters per second squared. 10 times 10 is 100, 0.3 of that is 30, so FF is 30 newtons. If you found either of these problems helpful, please like and subscribe. See ya.